Okay, so we're gonna go over quiz 3, rational expressions and rational equations. So let's begin. So number one, so let's look at this. First of all, we have these three equations, these three rational equations, P of x, Q of x, and R of x. This one says that P of x is the rational equation. Let's see. Okay. The rational equation x squared plus x minus 6 over x plus 4. Q of x is this rational equation. R of x is this one right here. Okay. Now, using that information, number one says to divide Q of x by R of x. And number two says to take Q of x and subtract R of x. Okay. So we have a division problem and a subtraction problem. And so we're doing these because division is like multiplication, right? So if you know division, you know multiplication. Subtraction is like addition. If you know subtraction, you know addition, right? So let's look at the first one. The first one says Q of x divided by R of x. So how do we set that one up? Let's zoom in a little bit. Okay, so Q of x is what? X plus 4 divided by x squared plus 3x minus 10. And it says to divide by what? R of x, which is this one, 1 over x minus 2. Now, dividing by a rational, this rational is just a fraction, right? How do we divide a fraction? We multiply by what? By this flipped over, by the reciprocal of the second one, right? So this is going to be, instead of 1 over x minus 2, it's going to be x minus 2 over 1. Now, before I write this one down, what's going to happen more than likely is that something's going to cancel out. Now, the x plus 4 is on the top. That one I cannot reduce it, but look at the bottom. The bottom is x squared. It's a quadratic. If I see a quadratic, it is very likely that I can do what to it? I can factor it. So how do we factor this? We're going to look for the two factors of negative 10 that add up to 3. So what are the two factors of negative 10 that add up to 3? It's going to be 5, 2. One of these is negative. Which is negative? The 2, because 5 minus 2 is positive 3. 5 times negative 2 is negative 10. So my two factors are going to be x plus 5 times x minus 2. So do you see that? So now I have x plus 4 over these two factors times, right, x minus 2. What cancels out? X minus 2 with this one right here. This one cancels out with that one. So what is left over? Just this part right here. The only thing that's left over is x plus 4 over x plus 5, and that's it. Now, it does say to identify the exclusions. The exclusions just means what values can I not plug in. These actually come from the part before anything cancels out. It comes from this step right here. So right here, I cannot plug in a negative 5. X cannot equal to negative 5, because what happens? I end up dividing by 0. And also, I cannot plug in a 2, because again, I will end up dividing by 0. So those two are not allowed. And later on, we find out that the negative 5, since it doesn't cancel out, is actually a vertical asymptote. Okay, so division is just like multiplication, except you just flip it. Okay, so that's the answer. This one is the answer for number 1 with those exclusions. Now, number 2 is the same thing, sort of. This one's Q of x minus R of x. So this is a subtraction problem. So subtraction, just like addition. So again, we're going to start off with Q of x is going to be x plus 4. And I'm going to go ahead and write, I already know that is the same one from before. So there's a factored form of it. What were the factors for this one? It was x plus 5 and x minus 3, x minus 2. And we're going to subtract 1 over x minus 2. So I have, right, so this is Q of x, is R of x, is this minus that. So how do I subtract one rational from the other? Okay, so subtraction is just like addition in that what? I cannot add or subtract unless the denominators match. Oops. So this one has to match with that one. Right now they don't match, right? What is missing from the second one? The x plus 5, right? This has an x plus 2. This has, I'm sorry, x minus 2, x minus 2. The x plus 5 is missing, so what? I'm going to add it, not add it, but I'm going to multiply it to the bottom and the top. So that way the bottom matches. So x minus 5 at the bottom, x plus 5 at the top. Sorry, x plus 5, x plus 5. So now they're going to match. So now I can subtract it. So once I bring them together, it's going to be what? X plus 4 minus, I'm going to distribute this 1. Okay? It's going to be minus everything to the right. So I'm going to use this in parentheses. 1 times x is x. 1 times 5 is 5. So plus 5. Over, now I have one fraction. Now I have one rational expression. Is going to be one denominator, x plus 5 times x minus 2. So now let's see if anything cancels out. So again, remember, we have minus everything to the right. So this minus also gets distributed. So what we end up having is going to be x minus x, which is what? They go away, 0. And then 4 minus a 5, 4 minus 5 is negative 1 over, nothing else cancels out at the bottom, x plus 5 times x minus 2. Okay. Now, one thing I want to point out about this one, actually, before I do that, what values can I not plug in? Negative 5, x cannot equal to negative 5, and positive 2. Now, one thing that I want to point out about this one is that, look, it's easy to confuse yourself. And look, we have an x plus 5 right here and x plus 5 right here. You might want to, it seems like they would cancel out, but that doesn't work like that. The only way they cancel out is if it's factors, like if it was x minus 4 times x plus 5. That's the only way they would cancel out. Since there's a minus, it doesn't work that way. So a little bit more cleanly, like if it said something like x plus y over x plus z, these two don't cancel out because of the plus. But if it was x times y over x over times z, these do cancel out because it's everything multiplied at the top, multiply at the bottom. Does that make sense? All right, so those are the first two. So add, subtract, multiply, and divide rational expressions. Now, the bottom part, this one right here, this one says formulate an equation, do not solve it. So this one is the work equations. Whenever you combine work, working alone, it takes Anjali 15 minutes to sweep a porch. Angela can sweep the same porch in 9 minutes. How long would it take if they work together? So for this one, remember I gave you the clue, or we use the template. We have two workers, work A and work B. So 1 over A plus 1 over B would be equal to 1 over the whole job, right? It makes sense that if you combine two people working, it's going to take less time, right? Because they're combining their efforts. So we just plug it in. Working alone, and Anjali takes 15 minutes, so this is work A to sweep a porch. Jessica can sweep the same porch in 9 minutes, so this is work B. How long would it take? Well, this is J, the one I don't know. So all this is just plug it in. 1 over 15 plus 1 over 9 is equal to 1 over J. Okay? And then you would have to solve for J, right? But in this one, it doesn't ask us to do that, so don't worry about that. Okay. Number 4. Number 4 says solve this rational equation. So there's an equal sign. So that means I can solve for x. I can try to find the value of x that makes it true. So let's do that. So right here I have 2/5 minus 7 over x plus 6 is equal to 9 over 5x plus 6. Before I combine any of this, right here it says to subtract this fraction minus that fraction. If I want to add or subtract two fractions, what has to happen with the bottoms? They have to match, right? So that means that they have to have a lowest common denominator, an LCD. So my LCD is equal to what? It has to have all the factors. This has a 5 right here. This has an x plus 6. This has a 5x plus 6. So this one has both. So which one is going to be my LCD? My LCD is going to be this one because it contains all the factors. Has this one and that one. Okay, so my LCD is going to be 5 times x plus 6. Now we have to change them. The way we change them is we have to tack on whatever it doesn't have. So for this one right here, it has a 5 at the bottom. So which one's missing? The x plus 6, right? So we're going to attach it to the bottom, x plus 6 at the bottom and at the top, right? What about this one here? What is this one missing? This one's missing a 5. So we're going to put it at the bottom and at the top. And by put, I mean multiply. This is called rationalization. So we're tacking it on. What about this one? This one doesn't need anything, right? It has both factors, so we're going to leave that 9 alone. So now let's simplify it. So x plus 6 times 2, this is actually going to get distributed. 2 times x plus 2 times 6 is 12 over 5 times x plus 6, right? Minus 7 times 5 is 35 over 5 times x plus 6 is equal to, what do we do with the 9? Nothing, right? It already has a 5 and an x plus 6 at the bottom, so I just leave it alone. 9 over 5 times x plus 6. Now look at this. We have 5x plus 6 at the bottom, here, here, and here. Whenever we have it at every term, they can be ignored. You can actually forget about them. All I have to pay attention is the top now. You can drop them. So I drop the denominators because all I need is what? The top. 2x plus 12 minus 35 is equal to 9. Combine like terms. 12 minus 35 is, let me get a calculator. 12 minus 35 is negative 23. So 2x minus 23 is equal to 9. Move the 23 over. So that's 23 plus 9, 32. 2x is equal to 32. And x by itself, we divide by 2, x is equal to 16. And that's all. Okay. And then the last one, all that one says is show that, so Sarah solved the following rational equation and she got a solution of 15. Is she correct? Well, let's see if 15 is the right answer. We have two options. We can plug it in or we can solve it like the last one. Since we already did the last one, I'm not going to do it that way. I'm just going to plug it in. You can do either one. You can solve it just like the last equation or plug it in. So that means wherever I see an x, I'm going to put a what? A 15 to see if it's true. So 2 times 15 is 30 over 3 times 15 is 45 minus 5 over 6 is equal to 5 over 2 times 15 is 30. So that's 5 over 30. I want to see if this is true or not. So let's get an LCD going to see if these match. So can I turn a 6 into a 45? Let's see, 45 divided by 6. I cannot. What about 90 divided by 6? Yes, I can. Okay, so if I make the LCD 90, all I have to do here is 2 times 2. This one is going to be 90 divided by 6 is 15. 15 over 15. And this one, to turn this into a 90, is 3 on the bottom and 3 on the top. So now this is going to be 2 times 30 is 60 over 90 minus 5 times 15 is 75 over 90 is equal to 15 over 90. So again, the denominators, I can forget about them. 60 minus 75 is not a positive 15. It's actually a negative 15. So this is not true. So is she correct? The answer is no. So you can either solve it and tell me what x really is, or just show that 60 minus 75 is not equal to 15, is actually equal to negative 15. And that's all.